It seems like scientific blasphemy to even ask. But has the universe been set up for us? Here's the thing. When scientists look far into the heavens or deeply down into the forces of nature, they see something deeply mysterious. If some of the laws that govern our cosmos were only slightly different, intelligent life simply couldn't exist. It appears that the universe has been fine-tuned so that intelligent beings like you and me can be here.
There's all sorts of fine-tunings that have to be matched in order for us to be here.
It's absolutely a huge issue for modern physics and astronomy.
Eminent 20th century astrophysicist Fred Hoyle was blunt.
It looks like a super intellect has monkeyed with physics, was the way he put it. He was very strong about this.
The problem is, to write the fine-tunings off as merely coincidences seems far-fetched.
Look, if I see my kid eating a chocolate chip cookie, and my kid said, oh, the cookie jar fell over and the cookie fell into my hand, will I believe that, or do I believe he stuck his hand in and grabbed the cookie? I believe the latter because the former explanation is so fine-tuned. The cookie jar would have to fall over at the right moment. His hand would have to be there just to catch it. That just seems unbelievable.
Some take fine-tuning as evidence that God created the universe. You can imagine physicists' horror at the thought. But what other explanation could there be? Well, we've hit the road to find some answers from some of the top physicists in the world. And let me warn you, we encounter some pretty mind-boggling ideas. Everything from black holes to the God particle, the Higgs boson, to some really bizarre ideas. Like the possibility of twin me's living in parallel worlds.
There could be an infinite number of Graham Phillips. There could be an infinite number of me. There could be a universe in which I'm interviewing you.
And our universe may not even be real.
It's true, aliens could have created our universe.
Yeah, there is a real possibility that we are living inside some elaborate computer simulation that perhaps some futuristic kid has set up in his garage.
But we're getting ahead of ourselves. To see some of these fine-tunings, let's start at the beginning, with the birth of the universe. It was here in LA that the first strong evidence for the Big Bang was found. Surfing was just taking off here back in the 1920s, when astronomer Edwin Hubble noticed all the galaxies in the sky were rushing away from us.
And, well, we say, if they're moving away from us now, earlier they were closer to us and closer to us and closer to us. And so we extrapolate that back to a time in which everything was on top of everything else, and that's what we call the Big Bang.
Modern astrophysicists, like LA's Sean Carroll, now know that our entire world was once packed into a space smaller than a grape.
And the amazing thing is we're talking about not only was the whole Earth squeezed into that size, but 100 billion stars in our galaxy and 100 billion different galaxies were all squeezed into a little region of space that big.
So it's hard to imagine with a straight face that we can talk about everything being contained in a region that small, but we can.
We've come to Seattle to catch up with Professor Brian Greene, who's on a conference here. He's a mathematical physicist who's devoted his career to trying to understand the cosmos and those earliest moments after the Big Bang. In reality, the universe began much more smoothly than with a chaotic bang.
It began to swell. People often think of it as an explosion. That's a little bit of a misnomer. It's really the big swell.
Indeed, the big swell was almost perfectly smooth, but not quite. And that's one of the fine-tuning mysteries.
If the Big Bang had been completely smooth, it would just stay completely smooth, and the history of the universe would be very, very boring. It would just get more and more dilute, but you would never make stars, you would never make galaxies or clusters of galaxies, so the potential for interesting, complex creatures like you and me would be there, but it would never actually come to pass. So we're very glad that there was at least some fluctuation in the early universe.
You can see the importance of some fluctuation by thinking about cloud seeding. When tiny crystals of silver iodide are released into a rainless cloud, they form centres for the cloud's vapour to condense around. These centres grow bigger and bigger, eventually falling as rain. The early universe also needed seeds for galaxies to grow around. And that's one of the fine-tunings. Those imperfections in the smoothness had to be just right.
But they're absolutely crucial. If those variations weren't there, we wouldn't be here discussing it.
George Smoot, who won the Nobel Prize for finding the imperfections, said, "If you're religious, it's like seeing God. We don't have original sin, we have original imperfection." To find out more, we went to the Parkes telescope, made famous at the movies, where sacrilegiously, cricket was supposedly played in this dish. John Sarkissian is operations scientist, and he's offered to let us hear the echo of the Big Bang itself. It's called the cosmic microwave background radiation.
This is the way to travel.
Yeah, it is great.
The early universe was very hot, and so was radiating heat like any other hot thing. Now, the heat's cooled a lot since the Big Bang, but we can still detect it. And that's the cosmic microwave background radiation.
It is, yeah.
It's the same radiation we use to heat food, only much, much weaker. The dish can pick up microwaves from space.
Hey, what's this? It's true. You do play cricket up here.
We don't talk about that. But this is the centre of the dish, Graham, and you can see it's 26 metres to the focus from here.
That focus is currently detecting the radiation we're here for.
Here on the spectrum analyzer, we can actually see the range of wavelengths that we're detecting at the moment. It's centred on about 10 centimetres, which is in the microwave region. It's about this long, the wavelength.
Now, the telescope is picking up microwave radiation from all sorts of places. But part of that is the cosmic background radiation, photons from the Big Bang. John converts all the photons into sound, creating this eerie hiss.
So we're actually hearing the photons left over from the Big Bang itself.
That's right. It's taken 13 billion years for the photons to arrive here at Parkes and for us to be able to put it through our system and for us to hear it.
That's incredible.
Yeah.
If we could see microwaves, the sky would have a uniform glow from the background radiation. Look at that glow in detail, and you can actually see those original imperfections. We've launched telescopes into orbit to observe the background radiation right across the entire sky.
And what they've done is map the entire surface out 13.8 billion years ago, look at that surface and take a picture of that radiation and look for changes in temperature, microscopic changes in temperature across the sky, which we think were imprinted at the Big Bang itself.
Up close, the smoothness of the radiation gives way to blotchiness. These are the tiny imperfections that allow us to exist. We travelled to blistering hot Arizona, where the great physicist, philosopher and writer Paul Davies now lives. He's particularly impressed by the imperfections. Even their size seems to be fine-tuned.
Now, it turns out that the level of those fluctuations is really rather crucial so that everything works out as we see it. If the variations had been a bit bigger, then instead of producing nice clusters of galaxies, it would be more likely to produce monster black holes.
That's because bigger fluctuations mean stronger gravity. Stronger gravity would cause matter to clump together so quickly it'd end up in its densest state, the black hole. A universe filled with only these monsters could not give birth to intelligent life. But smaller imperfections would have been a problem too. They'd mean weaker gravity. Matter would have trouble clumping at all.
If the variations had been a little bit less, then the galaxies may never have formed in the first place. So there seems to be a sort of Goldilocks zone of density contrast that makes things come out just right.
And why they're just right is a fascinating question.
And the original imperfections are not the only fascinating fine-tuning. There's another that's indeed the mother of all fine-tunings. It's to do with the energy of empty space itself. Remarkably, if you take all matter and all radiation out of the universe, you're left with something. It's called dark energy. Dark energy is an energy all empty space has. It pushes things apart. It's kind of like the opposite of gravity that pulls things together. Now we know it's there because astronomers have seen entire galaxies being pushed apart by it. Now the thing is, the strength of dark energy is preposterously fine-tuned.
The funny thing is, it's not a surprise that there is dark energy. The surprise is that there's so little.
The strength of dark energy is unimaginably tiny, barely above zero. To learn why this is so remarkable, we went about an hour south of San Francisco. Here at Stanford University is one of the giants of physics, Leonard Susskind, the co-inventor of string theory. Let's meet him.
So the dark energy is not exactly zero, but the first 122 decimal points are zero. That's crazy. That is really one of the craziest things we've ever discovered.
The amount of it is bizarre. It's a number that has basically a decimal point, 122 zeros, and something like a 138 at the end. It's hard for us to imagine starting with a theory, doing calculations, and after some number of pages of scribbling, having 0.00000, all these zeros, and then a 1 pop out of our equations.
The size of the dark energy determines how fast the universe expands.
Now the important point is here, it could have been anything. It could have varied anywhere from some gigantic explosive tendency to expand to some gigantic explosive tendency to collapse. Why it came out after everything was settled in this very, very tiny range, which allows the world to have expanded at not too fast a rate, we honestly don't know.
But one thing we do know is that intelligent life probably couldn't exist in the universe if dark energy wasn't just how it is. Another fine-tuning is the famous Higgs boson, recently discovered in the atom smasher at CERN. It's dubbed the God particle because it gives substance to all nature's other particles. But it too is just right so that we can exist.
If the Higgs boson were not also finely balanced in a similar way to the way the dark energy is, that would be very dangerous because it would in effect mean that gravity was much stronger. So the Earth would probably collapse into a black hole.
And there are many other fine-tunings, from the value of the speed of light to the charge on the electron. So what do we make of all this?
What do you say to people who say, look, you've found the proof that God created the universe here?
No,
you know that...
no, we haven't. Well, I am not going to argue with people about the existence of God. I have not the vaguest idea of whether the universe was created by an intelligence.
What's more important is...
Lawrence Krauss, who's made a film about atheism called The Unbelievers, gives God very short shrift.
It's certainly fine-tuned so we can exist. It's also incredibly inhospitable. If you were designing a universe for life, I suspect you might design it differently. There is no evidence of design or purpose to our universe.
I think somebody who looks at the universe and thinks it's been fine-tuned for us needs a good lesson in humility. We are these entities that the universe, I don't think, really cares all that much about. to think about the universe, this massive, enormous, expansive space with incredible number of stars and planets, for us, these little puny creatures?
Well, the question is God the best explanation for the existence of human life or anything else? Or do you have some other explanation?
There is another explanation some have suggested. God didn't create the universe, aliens did. We puny Earthlings are only capable of crude virtual reality at present, but alien VR could be much more sophisticated. We might be living in one of their virtual simulations without even knowing it.
If we could create a virtual world that was so sophisticated that it couldn't be differentiated from the real world, what's the difference? And the answer is, there is no difference. And so it's possible that we're a simulation on someone's computer.
It's possible, but scientists put that one in the too hard basket.
What does it matter? What does it matter if the origin of our universe was inflation, the Big Bang, or a kid in his garage? We still have life as we know it. I've still got my wife and my kids. It's fun. I'm just going to live it as if it were real, and in some sense it doesn't matter where it came from.
Another possibility is we just got lucky.
Well, one explanation for the fine-tuning is that's just how it is. Period. End of story. Accept it.
Fine-tuning could be nothing more than a coincidence. The way our human minds naturally work is when we see a coincidence, we straight away think something deep is going on. For instance, if 4 of my Australian friends suddenly turned up here on this Californian beach, I wouldn't think, hey, that's a fluke. I'd think, wait a minute, there's something going on here. Maybe they're planning a surprise party for me. But that very instinctive way of thinking we all have can be very misleading.
For example, the size of the moon in the sky is exactly the same as the size of the sun in the sky. That's why solar eclipses are so interesting, because you can see the atmosphere of the sun. Why is that true?
It's because of a remarkable matchup. The sun is 400 times wider than the moon, but it's also 400 times further away, making it appear the same size as the moon.
So it's useful for people who study the sun, but the reason that the moon and the sun are the same size in the sky is not so that astronomers could study the sun. It just happens to be a fluke.
That's a fine-tuning that there's not going to be any explanation for.
So, could the other fine-tunings be flukes too? Well, actually, the sun-moon match is not that accurate, only to 2 decimal places.
To 2 decimal places is not that crazy. What's crazy is to think a thing is a fluke if it's 123 decimal places.
That tiny value of the dark energy is a fine-tuning that demands explanation.
The only explanation that I know, and I think it's fair to say the only explanation that's out there, is that there are many, many possibilities for this number.
In other words, we live in a multiverse, a vast region made up of many, many universes where ours is just one of them. And each universe has a different value of dark energy.
We think that the universe we see is all there is, but it's very possible that there's literally other universes. They could be disconnected from ours, or they could just be very, very far away, and they could be the same laws of physics, but different cosmological conditions, or they could be even radically different laws of physics, different numbers of dimensions of space, different kinds of particles and forces.
So everything that seems fine-tuned in our universe could have different values in the other universes.
And if that's true, then there's a selection effect, that we are only ever going to find ourselves in the parts of this multiverse that are hospitable to human beings coming into existence.
Think of it like this. The Earth seems finely tuned so we can exist. It's the perfect distance from the sun for mild temperatures and liquid water. It has a protective giant Jupiter nearby to keep rogue asteroids from hitting us. All key requirements for intelligent life to evolve. But the Earth's not fine-tuned. The galaxy is teeming with at least 100 billion planets. By chance alone, there'll be at least one fit for intelligent life. In a multiverse teeming with universes, there'll be at least one that's suited to us.
You know, if you go to the shop and you want to get a nice suit, are you surprised when they have your size? Well, you would be if there was one suit and it just happened to fit. But if they've got a rack of every possible size, it's no surprise that they have one that fits you. If there are many, many universes with many, many different features, then it's no surprise that there's one that would fit us.
But the multiverse has a radical requirement. The laws of physics must be able to vary from universe to universe. And variable laws goes against centuries of astronomical thinking.
The physical equations that we've been using for many years now all make the assumption that physics is the same everywhere and always has been the same, but it is an assumption.
Could the laws vary from place to place? Tantalisingly, John Webb and his colleagues have found clues this could be true. They pointed powerful telescopes at bizarre objects out at the edge of the universe, quasars. They're massive black holes, perhaps 1 billion times heavier than the Sun. They beam out brilliant radiation, like torches pointing at us from the edge of the universe.
They're very bright point sources of light which we can use as beacons of light shining through the universe and illuminating anything that gets in the way.
When a cloud of matter gets in the way, the matter absorbs specific colours of the quasar light, causing those missing black bands. Now, if the laws of physics are the same everywhere, the bands should have the same pattern no matter where in the universe the quasar is.
And we found something that we didn't expect to find. So they change depending upon where you look in the universe.
Yeah, I mean, that's quite remarkable. I mean, standard physics says that those absorption lines should be the same everywhere.
That's right, that's what standard physics says. It doesn't seem to be what we're seeing.
That's pretty exciting stuff.
If it's right, it's very exciting, actually, yes.
Very exciting, because it'd be the first evidence the laws of physics are not set in stone, and so would at least open the door for the multiverse. But if the multiverse exists, it causes some serious conundrums, because it means there is a lot of space out there.
Well, matter of fact, the current data is consistent with our universe being spatially infinite, going on forever and ever and ever, and we're just seeing a small part of it. And over here, there's another universe, and over here, there's another universe.
And if there's infinite space, even the most unlikely things are bound to happen somewhere.
Anything that's possible will happen, right?
Lawrence Krauss puts it starkly.
Once you get to infinity, all sorts of weird things happen. Because if there are an infinite number of universes over an infinite amount of time, then it means that there are an infinite number of universes that seem like ours. And in fact, there are some universes in which I'm sitting there asking you the questions, and you're sitting there asking me the questions. So they're almost the same, but there are other universes that are precisely the same, where everything that happens to us now is repeated an infinite number of times. There are also universes where you and I and everything we see pop into existence by the laws of quantum mechanics 1 second ago.
As well as the bizarre consequences, another criticism of the multiverse is inventing unknowable extra universes is a cop-out.
In the beginning was a multiverse with a set of wonderful properties that we're not going to explain. The big problem with the multiverse is that we're trying to say, well, we can't explain this universe as we see it. We'll appeal to some bigger system which we really can't observe.
Instead of trying to explain away the fine-tuning with a multiverse, Paul Davies says we could accept that the universe has been fine-tuned to produce intelligent minds. After all, there is reason to think our brains are special, he says. Here's a great enigma. Evolution seems to have made our brains too good. Like all animals, we evolved through the survival of the fittest laws of the jungle. But our brains are able to do much more than just survive. We can understand complex mathematics, for example, and physics. We can do something so removed from daily survival as study the beginnings of the universe. Why? This fact bothered Einstein too. He remarked, the most incomprehensible thing about the world is that it is comprehensible. Maybe minds play a big role in the universe. even having a hand in designing it. Get ready for a truly mind-bending idea. Paul Davies thinks the universe is indeed fine-tuned for minds like ours. And who fine-tuned it? Not God, but minds from the future, perhaps even our distant descendants, that have reached back through time to the Big Bang and selected the very laws of physics that allow the existence of minds in the first place. Sounds bizarre, but quantum physics actually allows that kind of thing. It's like a loop through time, stretching from the far future back to the Big Bang. The future selecting the past, and the past allowing the future. Mind-bogglingly, both causing each other.
The universe, its laws, and its observers all explain each other in a self-consistent package.
As wacky as the idea sounds, it was championed by the extremely eminent physicist John Wheeler, famous for naming black holes.
He believed, the way he put it, that the laws of physics all came out of higgledy-piggledy. In other words, back in the Big Bang, the laws hadn't really sort of congealed. They were still very loose and approximate, and that as the universe expanded and cooled, the laws focused down on the set that we now have, which turns out to be a set which is friendly to life.
Of course, while this idea is consistent with physics, it is highly speculative. Then again, the existence of a multiverse is fairly speculative too. For the moment, the fine-tuning question remains unresolved. Next time on Catalyst, unearthing a treasure trove of fossils. Wings of wonder, bacteria shredding surfaces that could save lives, and the Australian Museum Eureka Prizes, a celebration of science. And please visit the special edition Custom Universe webpage, where you'll find a lot of extended interviews and extra information.